Hi, I'm going to show you this program. I'm going to load the data to I'm explaining because it takes a while. Well, this program simulate the water consumption of a house, of a Mexican house, compounded by three members. Um, First, with the first input is the day of simulations. The second one is the huge error limit. This huge error is related to imagine that we have a tube, a principal tube, and we make a hole. The area of that hole is the information that we put here. That's the huge error limit, and the probability is the probability that it happens. For example, if we simulate around 100 houses, and we put here a percentage of 10%. That means that maybe 10 of that houses are going to have the whole with a limit of this. Well, here it wasn't an error. Why? Because as we can see, we said that here was where we hadn't an error. Now, if I put here around 20% of, I want to put a very strong 100, and I'm going to say that I want a probability that it happens with a 30% and a small error limit on 20%. Well, the small error limit is with a probability of what is 45%. Now, if I run, what will happen? The smaller limit is different from huge because it is related to the percentage of the error per element of in our house. For example, if we have the kitchen and we know that I don't know, for example, that when I open the valve, its valve, it will have a consumption of 10 liters per second. I'm only being dramatic. It doesn't have to be that way. Well, that would we said that we have a 20%. We are going to relate that the error limit will be the 20% of the 10 liter per second, and it will occur with a probability of 45%. It is important to say that the existence of each element of the house is related to this probability, and it will have its maximum limit related to that. The error is calculated with a normal random function from Matlab, and it will be centralized in the middle of the magnitude of the error, and it will have a standard deviation of the square root of that center point. Well, this is still working. Let me. Well, I don't know. Yeah, it is still working. I only kind of stopping the video in order to not make it so long. So I'm going to return when it starts to show the data. Well, here it is still running. Well, now it finished, and you can see results. For example, if I want to load the previous data without simulate, I only have to press here, load and show, and it will start to show the simulation. You can see that it was 10,000 faster than the previous option, and it is making some calculation, and it will say us that we had an error. Yeah, you can see that it says that a leak was detected. Now I'm going to show you how it runs using Simulink. I'm going to open it. It will take a while. Well, I'm going to show you how that works. I'm going to put here. You can see that in the previous simulation, the huge error was off. So I'm going to force to be shut on, to be on. And how I do that? Saying that it will happen with a 100% of probability. So I'm going to say that will be on. And here we're going to slow down until 30%. And we're going to go up to 30%. Now I'm going to show you how that works. It started a simulation. Now you're going to, well, it hasn't started to compile, but in a moment it will happen. You can see here our Simulink using a Simscape libraries model. You can see the daily waste, the error, and we use integrator to get the accumulated waste. Now if I go to it started to running, and you're going to see the behavior. That's funny because the consumption is strongly related. It seems like an offset. That's weird. Well, it should end quicker. Well, what happened here? Well, it seems that the error was a constant hold. That was funny. I'm going to run again to show you a more chaotic. I'm going to see what happened here. Yeah, you can see that we only had a huge error. I'm going to make this more severe, this probability more severe, and I'm going to show you what will happen. While it is running, I'm going to show you, for example, the daily consumption blocks, and well, you can see how it is compiling again. Here in this section, you can see how we combine Simulink and Simscape. This the blue shaded one, it's the Simulink libraries. You can see the water source, or fluid source, about a sensor and a tube. These blocks are provided by Simscape. Right now this is running, and you can see how an error happens, and you can see the like a noise behavior. This signal error was done using a normal random function that Matlab has, and I'm going to show you the results. Finally, after this simulation, I'm going to show you what happens when we have a simulation with no error, without error. Well, in the last one, I'm going to show you that we don't need to have Simulink open it. We need to run this program. We need Matlab, Simscape, and Simulink libraries. Well, Matlab is a program. Well, you understand. And it's done. And we're going to see what happened. After the simulation was done, it opened again in our environment. And well, you can see that we have another figure. That this figure is related to the machine learning algorithm, and this it only shows us the comparison between the current daily waste and the accumulated waste. And of course, we should have an error. Yeah. Right now, I'm going to close this scope and the Simscape, Simulink interface, and I'm going to put an 0, 0 with 0 probability. I am going to start the simulation, and we're going to wait until we got our chart. Here you can see that in the previous simulation we had a huge error. An error was on the W, well, in the restroom and in the dishes or in the kitchen. Well, it started to show us the results. You can see how the current with no error and with error are superposed, or without error are superposed. Why? Because we turn off the errors. You can see that we don't have any errors. Well, I forgot to program this to become blank. It doesn't matter because it wants to say that we don't have any error. If you want to see more or see the documentation, you can see to my GitHub. I'm going to put the link below. So thank you for watching.